Welcome to Lecture 8 of Physics Concepts. Today, we will explore the fascinating world of rotational motion. Understanding rotational motion is crucial for comprehending various physical phenomena and applications. Let's start with some key terms. Tangential speed refers to the linear speed along a curved path, like in circular motion. Rotational speed is the number of rotations or revolutions per unit of time, often measured in radians per second. When a phonograph record turns, a ladybug farther from the center travels a longer path in the same time, having a greater tangential speed. The entire disk rotates at the same rotational speed, but distances from the center affect tangential speeds. Rotational inertia is the property of an object that measures its resistance to any change in its state of rotation. If at rest, the body tends to remain at rest. If rotating, it tends to remain rotating unless acted upon by a net external torque. Rotational inertia depends on the distribution of mass with respect to the axis of rotation. The tendency of the pole to resist rotation aids the acrobat. Which stick has greater rotational inertia? The one with mass farther from the axis. Torque is the product of force and lever arm distance, which tends to produce rotation. Equilibrium is the state of an object when not acted upon by a net force or net torque. Moving the weight away from the hand increases the difference between force and torque. When torques balance each other, no rotation occurs. The magnitude of force and lever arm affects the torque produced. The center of mass is the average position of the mass of an object. The center of gravity is the average position of weight or the single point where the force of gravity can be considered to act. The center of gravity of the Leaning Tower of Pisa lies above the base of support, keeping it in stable equilibrium. Why do you keep your legs far apart when standing in a bumpy bus? To keep your center of gravity above your feet. Centrifugal force is an outward force experienced in a rotating frame of reference, appearing as a result of rotation. Centripetal force is directed toward a fixed point, causing circular motion. When the string breaks, the whirling can move in a straight line, tangent to the circular path. This is centripetal force, directed toward the center of circular motion, not outward. Angular momentum is the product of a body's rotational inertia and rotational velocity about a particular axis. Conservation of angular momentum states that without external torque, the angular momentum remains constant. A small object of mass m whirling in a circular path with radius r and speed versus has angular momentum mvr. Conservation of angular momentum means that when the man pulls his arms inward, his rotational speed increases. Thank you for watching. Please like, share, and subscribe to this channel. Add a comment below the video for the benefit of other viewers. What did you learn from the video? What topic would you like to explore further? This presentation contains copyrighted material used under the Fair Use Doctrine for educational, commentary, and research purposes. All rights belong to their respective copyright holders. Links are provided in the video description to relevant resources.